We're going to try a couple of cars that are on a collision course with one another, and we'll make up a story for it. Okay, like we'll say that there was car A and car B. Car A, let's label this up, was seen by a traffic camera. And we'll pretend that it's reasonably easy to figure out how fast a car is going. I mean, of course, a camera is going to have a time index built into it. We can get some relative scaling measurements and all that sort of stuff. We can figure out how fast this car was going. 13 meters per second. Let's just say these two cars are the same mass. They're like the same make and model, which I know is unlikely. It also would require that the riders be roughly the same mass. But just for nice, easy numbers, we're not going to cancel the masses out or anything like that. Just to let them be a simple number. And we say that we have a reference frame. So there's a north, a south, an east, and a west. And because these guys are going sort of north for one of them and east for the other one, let's make north and east be positive and west and south be negative. But what we can say is that px for the whole system is equal to px primed for the whole system. And if we expand that out, what we get is that equation 1 and equation 2 that we've been talking about. MAVAX plus MBVBX. Oops, not plus, equals MAVAX primed plus MBVBX primed. I'm going to put a line straight down the middle of my page, just to organize myself as I do this. Now let's tell a story. So there's a police officer, shows up at the scene, of an accident. Driver B, you always take the people's testimonies or whatever it is we call it. We interview them. But driver B claims to have been driving. This is a claim. At 11.33 meters per second north. Now that's a very specific claim, and anytime somebody claims something that specific, you should question it, right? So 11.33 meters per second. The officer observes skid marks on the ground. In the direction east 55.0 degrees north that follow the path of the wreckage. Okay, so this is the scene that we've set. And these all seem like reasonable things that the police officer could observe, right? They may or may not have access to the camera footage. Let's leave that up to the insurance people later on. Maybe they come back and they report back and there's some dialogue from the city. I don't know how this is going to work because I don't work for any of these agencies, right? But as we look at this accident investigation, which may or may not be the scene of a crime because this person may have been speeding when they had this accident, and it could be like the streets near the school. People might look at like New Street or one of the cross streets, right? So like one of these northbound streets and one of the east-westbound streets. We might say, okay, well, for this situation, it looks like if I look at car A at least, I could say the momentum in the x direction is equal to mass times AX. Sorry, mass A times VAX. Nice round numbers. We get 1,500 kilograms times 13.00 meters per second. And that gives us a nice round 19,500 kilogram meters per second. That's just what car A is driving. We saw it on camera. And we can also say that based on the claim, and I'll underline that it was a claim of driver B, PBY is equal to really PY total. Isn't this also PX total? It's the only X component, right? So maybe we'll throw that in there as we're thinking through this situation. PY total would be MB VBY. And so just based on the person's claim, and you don't always take their word for it, we're going to investigate whether they were honest or not. 11.33 meters. I mean, how could any of us really measure how fast we're going that accurately, right? Now again, I've done this math, so you check me. Make sure that I'm not doing any typos here. I got 16,995 kilogram meters per second. Did anybody just check my facts on that one? All right, fact check follows. All right. I'm going to block this out. I've got to keep on with my thinking. It seems to me that this person's contributing all the X momentum and this person's contributing all the Y momentum. And so if momentum's going to be conserved in the X direction, let's just concede that that one's 0, right? Now, in the Y direction, what happened to this thing? Well, it looks like there was a path of the wreckage. I'm going to infer from that they stick together. Sometimes that happens with the cars. They're going to stick together as one body and slide together across the ground. So that means that my after momentum, really, whatever VA primed and VB primed are in the X direction, they're just going to be VX prime. They're going to be moving together, right? They're all kind of sliding together. That's just me trying to make sense of this horrific incident. Anyway, when I go to look at my P total equals P total primed, down here, I'd like to compare my before and after, but I think I got to take a look at what was happening before I can discuss what was happening after. I know that P total primed should be equal to P total, which means that I should be able to have a P total X that goes off this way, not primed, just P total X, and P total Y, not primed, just P total Y that goes this way. And it should be that whatever angle I come up with for the triangle from those two should be the same angle as what was actually observed in the skid marks. If everybody's all honest, right? If everything is as it was stated. So let me just make a statement here. If theta is greater than, actually let's find the calculation. Maybe before I do my if-then statement. Let's find our theta value. I'm going to leave a blank here. We'll come back to it, okay? So based on our values, we say tan theta is equal to P total X, what did we get it to be? 16,995 kilogram meters per second. P total Y was 19500 kilogram meters per second. Tan theta is going to be P total Y, that's the opposite, over P total X. Theta all by itself going to be equal to tan inverse of 19500. Oh, I missed. No, did I miss a 0? 19,000.
Mr. Keelan,
Yep.
I think you have your values backwards on
Did
the
I?
diagram.
Oh, shucks, I do. Thank you for saying something. That would have messed us up, wouldn't it? I hate when that happens. P total Y, thank you for catching it, is the 16,995 Oops. Thankful for editors. Kilogram meters per second. And I got it right this time, right? All right. So it's still going to be opposite over adjacent, though. And I got 41.07. Fact checkers? Okay. 41.07 degrees. And we could say, okay, well, therefore, the car, oh, wait a minute. How am I going to use this angle to figure out if car B was telling the truth or not? Let's think about this. I'm going to go back up here. Let's do an if-then statement. If theta, which it was 55, the actuality was that it was 55 degrees. So it was greater. So if theta is greater than what we just calculated, 41.07 degrees, what must be true about the car traveling north? Were they going faster than their claim or slower than their claim? Think about it. If the actual angle wasn't this, it was larger than this, what would have to be true about P total Y? Must have been bigger, right? The only way for P total Y to have been bigger was for what to be true about the car's motion? Had to be, yeah. So I can say, so and in a nice little if-then statement, then VB was greater than 11.33 meters per second. Aha! They were lying about their speed. But we got to go back and figure something out. How fast were they actually going? Because to lie about your speed isn't like, you know, maybe it was a mistake. You know, it doesn't mean you were speeding. And if you caused an accident while you were just going like the right speed, but you just couldn't tell what speed you were going at, that's not a crime. Well, I mean, the accident's still maybe not a good thing, but I mean, maybe you weren't speeding. So let's figure this out. How fast was car B going? There's always people that are upset if I leave an unfinished sentence. So the car was going faster. I'll just finish that sentence just so it's not an unscratched itch. But back up here, how fast was the car going? Well, let's reconstruct this after momentum triangle again. P total primed is going to be equal to P total x primed, P total y primed. And what I know for sure was that, because we had it on camera, car A, traveling in the x direction, had a momentum of 19,500 kilogram meters per second. The other thing that I know for sure, because the officer saw the skid marks, was that the theta value was 55 degrees. And so we should be able to calculate that y component using trigonometry. What trig ratio do you like, sine, cos, or tan? Seems like tan, doesn't it? We've got an opposite and an adjacent there. So we can say, all right, tan theta equals opposite pty prime divided by adjacent ptx primed. Want to get the pty primed all by itself, so we'll do a little bit of algebraic gymnastics. Vty primed is equal to ptx primed times tan theta. I get a number that starts with a 2. What do you guys get? Yeah? Nice. 86 kilogram meters per second. Now, how am I going to use that information to figure out how fast this thing is going? Yeah,
P equals MV.
P equals mv. Sounds good. So P total in the y direction was equal to, really it was equal to, once upon a time we said, remember P total y was equal to just mb times vby. We have vby all by itself, P total y over mb. It was a 1,500 kilogram car. I know somebody's already got this one. What'd you get? Yep.
18.5659.
9. And it's just meters per second. Now, you know, when we drive cars and when we set speed limits, though, we typically want to record our speeds in kilometers per hour. So if we're going to kilometers per hour, we're going to multiply by 3.6. How fast are we going now? And maybe I should add, this is a residential zone. How fast are we going? Starts with a 6. You guys. All right, fine, I'll do it. 66.83 kilometers per hour. Now, if this is a residential zone, how many people know what the speed limit in our city is for residential? Yeah, 40. We're doing more than 1.5 times the speed limit. Now, the thing is, that is greater than 40 kilometers per hour. I see people doing that in my neighborhood all the time. They put in speed bumps, they put in stop signs, they put in, I don't know, flashing lights in some places. But people are doing this. And the thing is, if this accident happened, the math isn't so hard. We did it on one page, and would you believe there's probably an app for that? Just pop in a few of these variables and it comes out the other side. Put in the masses of the cars, and it'll do a lot quicker for us. But for us, it's not just about, oh man, well, I guess I shouldn't learn this because there'll be an app for that. You want to be the person, the coder. You want to be the investigator. You want to be the designer, right? So, I mean, this is the basics for how the app for that would work. And we can investigate it fairly quickly. Anyway, it follows the laws of conservation momentum. It's very, well, legal in every way.